All right, welcome everyone to our 2022 Department of Civil Construction and Environmental Engineering 3-minute thesis competition. It is a day to celebrate graduate students' efforts and achievements, and well, this is just really nice to be in person this year. So next slide. I am one of the co-EM CEEs for this. I'm Laura Dalton. I'm a soon-to-be graduate of the department. Here in May, I'll be graduating. And then we have...
I'm Savannah Smith. I will not be graduating in that timeline, but I will graduate.
And today we have 3 judges who have kindly taken time out of their days to help us judge our contestants. And so we have Dr. Nehemiah Mabry, and he's the founder and CEO of STEM Media and a bridge design engineer at Simpson Engineers and Associates. We also have Danielle Herman, who is Associate Director of Communications at NC State College of Engineering. And we have Katie May, who is Director of Community Engagement, Core NC State Center for Environmental and Health Effects of PFAS. So with that, hand it over to Savannah to present what 3-minute thesis is.
So 3-minute thesis is a competition that was founded by the University of Queensland and has since become a worldwide competition that many universities put on. The contestants are allowed a single static slide and 3 minutes to effectively communicate their research to a broad audience. So we're going to kick off the CCEE 3-minute thesis with our first contestant, Esmeda Narode. Esmeda's favorite place on the NC State campus is the Skyline Terrace of Hunt Library. She's a 5th-year Ph.D. candidate advised by Dr. Morton Barlaz, and she can solve a Rubik's Cube in under 5 minutes. Maybe after this we can have a Rubik's Cube competition?
I used to be able to, I don't know if I can do it anymore.
Her 3-minute thesis is titled Hot Landfills. Take it away, Esmeda.
Thanks, Savannah. All of us generate half a bucket of trash every day. You probably never think about this trash after you put it in a trash can. Where does this trash go? It goes to a landfill. Civil and environmental engineers design and maintain a landfill to protect human health and the environment. Various kinds of things end up in a landfill. One such component is ash. Ash is a byproduct of coal and solid waste combustion, and every year, millions of tons of ash end up in a landfill. And this, when the ash goes to landfills, it reacts, goes through various chemical reactions, and can get really hot. Sometimes as hot as boiling water. These hot landfills are called elevated temperature landfills. You might be wondering, why is it bad for landfills to experience high temperatures? When landfills get too hot, there is a risk of infrastructure damage, and polluted water and greenhouse gases can get released into the environment. This can increase the water pollution and air pollution around the community, and also can contribute towards global warming. It takes millions of dollars to repair these landfills, and can you imagine the amount of effort required to find the damage, excavate all the waste, and then repair it in a structure that big? My research focuses on understanding how ash contributes to elevated temperature landfills and finding ways to prevent them. Ash goes through various chemical reactions in a landfill, but we cannot accurately estimate how much heat is generated from ash in a landfill, which is what we are trying to measure. By measuring the amount of heat generated before ash is buried in landfills, we can prevent elevated temperatures and the detrimental effect it causes on the environment. To measure heat generation, we developed a method which simulates landfill conditions and measures the heat generated from ash in a landfill. We physically simulate landfill conditions like water and carbon dioxide around ash, and we measure the temperature increase. Then we use a model to estimate the amount of heat the ash can generate in a real landfill. Using this data, various strategies can be implemented. These strategies include burying ash in a landfill away from solid waste, or adding water to it before it is buried, or even reducing the amount of ash which goes to a landfill. Using this research, we can improve life of a landfill. We can reduce the detrimental effects elevated temperatures have on human health and the environment, and make landfills cooler again.
Great job. All right, so we have a question for everyone. I guess this is something our school does, where we take an image of Mr. Wolf here, and it's an obscured image, and you're supposed to guess where he is. So I'll give you guys a couple minutes to guess where the wolf is, if you can tell from this image. Actually sounds like everyone knows. Okay, I did not know where this was. Okay. Yeah, someone knows? Okay. The dairy farm, yeah. So there's a Howling Cow Dairy Education Center and Creamery that you can visit and learn more about, I guess, how the ice cream's made and everything. So that's really fun. So that's where it is. However, that would be a terrible place for an actual wolf to be with the cows and everything. But, you know, there's that. But all right, we have our next contestant coming up in a few minutes. Oh, all right. When the education center is located at 100 Dairy Lane, in case anyone wanted to visit. Good. Okay. We have our second contestant, Gofun Chen. And a fun fact about his name is that Gong in Chinese actually means indomitable man, while Fan means ordinary person. His father wanted him to be great, and his mom wants him to be a normal person. So that's where his name originates from, which I thought was very interesting. He is advised by Dr. Min Liu, and he is and our contestant is from a southern province in China. He is in his third year of construction engineering and management. And a couple other fun facts are that he loves or is very good at painting and calligraphy, which is great. You know, not too many engineers are very artistically inclined, so that's really interesting. And the most common place you would find him is on the gym basketball court. So with that, go ahead.
Okay, thank you. Imagine Chris is the general manager for a construction project. Every day he needs to spend tons of time to track performance, identify the construction progress, communicate with different stakeholders, and assign payments. He's the central decision maker for the project. Everyone is counting on him to make sure everything is on the right track. What if I told you that there is a way all the project participants will perform their works automatically without the supervision of the Chris? You definitely think that's a nonsense. Well, this is what smart contract and blockchain can do. Smart contract and blockchain might sound scary to you, but the idea is pretty simple. Everyone knows a vending machine, right? To purchase a beverage in a vending machine, the only action is to throw in the cash, and then the beverage will release automatically. There is no third party to assist you to finish the transactions. Why? Because people already write the programs in the vending machine to achieve such simple transactions. Smart contract works as the same way. It is basically a set of computer codes specify various if-then conditions. Once a certain condition is satisfied, then the transaction will be executed automatically. All the information will be recorded in a distributed ledger. We call it blockchain. So everyone keeps the same ledger and takes the responsibility of maintaining the ledger. No one can cheat in such a trustworthy environment. Therefore, we can use the smart contract in construction management to guarantee you pay what you done what you pay. However, in order to make smart contract work, the key is to derive rules before the project starts. Construction projects are dynamic and ever-changing. If the precondition is not efficient enough, it'd be hard to execute the terms accurately when facing different situations. Therefore, in my research, I implemented a simulation model to quantify the performance levels for subcontractors and exhaust all the possibilities. We generalize those performance scenarios as if and use the cost outcome as then to form the contract terms. We program these concise and comprehensive rules in a smart contract to enforce the reliable performance for the subcontractors. So once a certain performance is detected, the payments and action items will be triggered automatically. All the information are transparent in the blockchain network, so subcontractors can negotiate proactively. Therefore, my research helped the project manager save time and cost, build a trust for subcontractors, and yield more reliable project outcomes. Thank you very much.
Okay, to go. Okay, well, we can start with this. All right, so many of you know Dr. Ranjithan as the director of graduate programs in our department and as a leader in modeling analysis of energy systems. But how well do you really know him? Here we present two truths and one lie about our director of graduate programs. So A is Dr. Ranjithan originally from Sri Lanka. B, has he lived in the US for more than half of his life? Or C, has he visited every continent in the world? Oh, do you know? Wow. Oh, go. Yeah, sure. Yeah, sure. Jewish, yeah, okay, let's go with A. So who thinks it's A? It's the lie. So we're going with what would be the lie. Okay, what about B? Wow, C? Okay, all right. Okay, all right. So, correct. But he has made it to 6 of the 7, which is pretty impressive. So, very fun. That's a goal on my list, too. So, I'm pretty envious.
Next up in our competition is James East. James is a fifth-year PhD candidate advised by Dr. Fernando Garcia Menendez. James has finished multiple times in the top 10 of racers at the Bear, which is a 5-mile foot race from the bottom to the top of Grandfather Mountain. His favorite spot on this campus is the Lake Raleigh Disc Golf Course just down the road, and his 3-minute thesis is titled Understanding Our Air from Space. The floor is yours.
Before we begin, I'd like everyone to please take a deep breath with me. In and out. Great. We all just collectively respirated about 50 gallons of air. According to the American Lung Association, a person breathes on average 2,000 gallons of air every day. Now, imagine if some of those 2,000 gallons of air that you and I breathe every day were actually made up of harmful gases or were carrying tiny particles that stick deep in our lungs. For the majority of people in the world, breathing polluted air is a daily reality with serious health effects. In 2019, the WHO estimated that 90% of all people in the world were exposed to unhealthy air. Where is all this pollution coming from? If we want to do something about it and clean it up, we first need to address that question. But that can be a difficult question to answer. Fortunately, there are some tools to help us out. In my research, 2 tools help answer this question. The first is satellite data from a NASA satellite. The second is a 3D computer model of air quality. The computer model simulates the atmosphere of the Northern Hemisphere. It connects the sources of air pollution to its impacts. It's used by policymakers in the US to regulate air quality so that our air stays clean. In order for the results from this air quality model to be meaningful, the model needs to know all of the pollution emitted in the Northern Hemisphere, but that's almost impossible to actually know. Many scientists work hard to compile emissions data from around the globe, but inevitably there are gaps. That's where the satellite data, the first tool that I mentioned, comes in. This satellite is orbiting the Earth right now, measuring a pollutant called NO2, or nitrogen dioxide. I used the data from this satellite to create the image up on the screen. I fused the NO2 data from the satellite with results from the air quality model. And by seeing where the two have differences, I can see where the model is missing some emissions information, and I can fill in the gaps. Then, armed with this new information, I can go back and better simulate the sources and impacts of air pollution. Sometimes those impacts can be far-reaching. For example, say you decide to take a trip to the scenic beaches of California. While you're there, you could be breathing pollution formed from emissions in China, while someone else could be breathing in pollution formed from the plane or car that you used to get to the beach. This research helps fill in the gaps in missing emissions information, and it quantifies the long-range impact that I just described. And hopefully it helps us get one step closer to cleaner air for everyone. Thank you.
All right, we have another kind of fun fact for everybody here. All right, so we have our brand new building, which is wonderful, and it's nice that we're using it for this event today. But how many civil construction and environmental engineering research labs are there in the building? Don't know if anyone knows or what you guys think, and I will say this is subjective to me walking around and deciding what I thought was one research lab compared to another, so take that how you will. But so who thinks A, 10? Anyway, we'll just do a raise of hand. A, 10, okay. One, couple, okay. B, 15. All right. Or C, 20. All right. Can we go to the next slide? It's closest to 15, okay? Like, that's what I'll say. It might be like 14, but yeah. Because, I mean, even our lab with Dr. Porgas, we technically have 3 labs, but it's 1 lab. So that's how I came up with it. But yeah, I'd say closest to 15. So fun fact for everyone in the room. We're good? All right. Our next contestant is Adam Schmidt from Greenville, North Carolina. Adam is advised by Dr. Bardaka and is in his 2nd year of his PhD in civil engineering. An interesting fact about Adam is that he, at one point in time, played 3 different instruments: the violin, trumpet, and French horn, which, again, artistic. I'm really impressed today. And his favorite spot on campus is the Court of Carolina on main campus. And the title of his talk is The Social and Economic Impacts of New Transit Systems. Take it away.
You've probably heard the saying, if you build it, they will come. But have you ever wondered who they are or what they bring with them? This question is particularly tricky for transportation researchers like me. For decades, we've been wondering who will come and what changes they'll bring with them when we build new public transit systems. Rail transit is especially important to study because it often costs billions of dollars to construct, and it physically changes our neighborhoods when we put the rails in the ground. Behind me, you'll see headlines from local news outlets in Charlotte, North Carolina that show rail transit systems sometimes actually hurt the communities that need access to transportation the most. So to do better than that, it's important that we understand where transit systems will have an impact and what the scale of those impacts will be. Researchers trying to figure this out in the past have mostly looked at the relationship between the price of housing and the arrival of new rail transit. But their methods have assumed that all homes in an area are affected in the same way, regardless of if a house is 50 feet away from a transit station or 5,000 feet away from a transit station. It's also only been in the past 5 years or so that researchers have started to look at the relationship between transit and larger social and economic issues like gentrification. And research on that subject has assumed all neighborhoods experience gentrification equally, regardless of their initial social and economic characteristics. But these are big assumptions, and my research helps us move past them. I use advancements in a kind of applied statistics called econometrics to get a more holistic and detailed understanding of how transit changes our neighborhoods. Using data from Charlotte, North Carolina, I make careful comparisons between the neighborhoods that got light rail transit stations and similar neighborhoods that didn't. I also account for individual differences in home and neighborhood characteristics to really understand how neighborhoods change because of the arrival of new transit infrastructure. My work shows that homes near the Charlotte light rail system increased in value between 8 and 20%, and that change was most notable for homes between 1/4 and 3/4 of a mile from light rail stations. Looking at gentrification, I found that lower socioeconomic status neighborhoods were some of the ones most likely to experience the changes associated with gentrification, especially right after light rail transit opened. So what does this mean? If we build it, change will come. But cities across the US can use the methods from my research to anticipate what that change will be, design affordable housing and property tax relief programs to prevent headlines like the ones you see behind me, and ultimately move us towards a more equitable transportation future. Thank you.
So many of you are probably familiar with Dr. Barlaz as our department chair and also as a leader in solid waste research. But how well do you really know him? We have 2 truths and 1 lie up here. So you have to pick out which one is the lie. Is it A, that every Thanksgiving he requires his family to listen to Arlo Guthrie's Alice's Restaurant? Is it B, that Dr. Barlaz had a buzz cut for most of his life until recently? Or C, his grandchildren think his name is Cool Grandpa? Who thinks it's A? Who thinks it's B? Who thinks it's C? You don't think he's a cool grandpa? If you chose B, you were right. He used to have even longer, luscious locks than he does now. He willingly shared these pictures. We did not stalk the internet for them, but I do appreciate it. I can send them to you later. Our final contestant is joining us virtually all the way from California, Jian Lo. She's a fourth-year PhD candidate and is interning in Berkeley, California. But even though she's moved there over a year ago, she's still never been in the office thanks to a certain coronavirus. When Jian is in North Carolina, her favorite spot on campus is actually this building. She's only been in here twice, and one of those times she got lost, but she still likes it. She's advised by Drs. Jeremiah Johnson and Fernando Garcia Menendez, and she'll tell us about diverse pathways for power sector decarbonization yield health co-benefits but fail to alleviate air pollution exposure inequities.
Let me start my presentation with a harsh question. Do you believe that we are all born equal? Of course we should, but are we? I cannot hear your answers, but my answer would be a big no. While I'm staying in my tiny but cozy studio with AC running 24/7, some people are born without access to electricity, and some are born to experience more hurricanes. We are even born to breathe different air. We have learned that minority and lower income populations have been historically experienced disproportionately high and adverse human health and environmental impacts. It's important to keep this lesson in mind when planning for the future, a decarbonized future. You may hear the word decarbonization quite often, which means eliminating carbon emissions, the only solution to climate crisis like rising sea levels and extreme weather. So will everybody be happy in a decarbonized future? My work investigates some common decarbonization strategies used in the power sector, the biggest carbon emission sources in the United States. And I can tell you that we as a big group benefit a lot from power grid decarbonization through air pollution mitigation. But the bad news is that we as individuals do not benefit equally from decarbonization. Each demographic group has its own geospatial distribution, and power plants are not evenly distributed. People of color and people with lower income who have already been suffering more will still bear a disproportionately high environmental burden in the future, where the air pollution caused by human activities should be reduced to the minimum level. Distributional impacts are always hard to be considered in decision-making process, but this is exactly why we need to plan more carefully to equally protect people from environmental degradation. Transitioning toward a cleaner energy system is not easy already, but transitioning to a just future can be more challenging. As an engineer, I hope my future work can provide more cost-effective solutions to a just energy transition. Thanks.
All right, you now have 3 minutes to go to this link here at the bottom of the page and cast your vote for the People's Choice Award. So this is really up to you, however you think did well for whatever reason you deem appropriate. You can go ahead and vote for the next 3 minutes. All right, Dr. Ranjitham will now present graduate student awards. These awards have nothing to do with this event, to my understanding, but it's a convenient time to get everyone in the same room, I guess. I don't know.
Did you guys figure out what the pineapple was all about? Good afternoon. So every year we ask the faculty in the different areas to nominate students from their group who excelled in either academic, research, leadership, service, whatever the criteria may be. So we have nominations from all groups. Proud to announce that we have 12 awards to hand out. So I'm going to read the name, and if you're here, not all are here, so if you're here, please come up here with your advisor or whoever is representing you today. And when you come up here, I'll give you the certificate. The cash is in the mail, and I'll give you the certificate. And Taylor is going to take a photograph of the winner, and then with the faculty member that they are here with. And where do you want them to stand? Here?
Actually, like right at
Right here. So there's an X on the floor here. So you have to stand on the X. So two of you have to stand on that one X.
around
All right. So with that, I'm going to just read out each name. And we have 12, as I said. We are like Amazon. We have A to Z. You will know what I mean by that. Like I said, I'm going to read out in alphabetical order. So the first is for Abdullah Fahad Al-Sarif. He's a PhD student who graduated from construction engineering, was advised by Dr. Jaselskas and Dr. Albert. Oh, God, 3 people to stand on one X. Okay. All right. So the award is a Smith-Gardner Graduate Award in acknowledgement of his achievements in construction engineering. Next is Tanmay Das, who is a PhD student in transportation systems engineering. And the advisors are Billy Williams and Dr. Raphael. I know Billy Williams is getting late, so we will just go through and announce it for interest of time. And Tanmay Das is, like I said, is a PhD student, and he's receiving this award, the Ed Wick Transportation Graduate Award, in recognition of his contributions in transportation systems engineering. Next is Urmi Dervi. She's a PhD student in structural engineering and mechanics. She's receiving the Thomas Griffin Graduate Award in recognition of her academic excellence, research achievements, and contribution in her field of research. And I don't see her here, and her advisor is Jason Patrick. Next recipient is Abdul Rahman El-Maliji, and he is a PhD student working with Dr. Gudati in the structural engineering and mechanics area, and he's receiving this award, Thomas G. Coffey Award, in recognition of his excellence in academic research and research excellence. Next recipient is Mehdi Hasnat. Mary is a PhD student in the Transportation Systems Engineering area, advised by Dr. Badaka. And he's receiving the Ed Wick Transportation Graduate Award in recognition of his academic and research accomplishment in transportation systems engineering. Next recipient is Do-Yoon Lee. Do-Yoon Lee is a PhD student in the construction engineering area. He's receiving the Thomas Coffey Award in recognition of his excellence in research and academic contributions in construction engineering, and was supervised by Dr. Min Lu. My apologies that he's advised by Dr. Kevin Han. Next recipient is Chuani He. He's a PhD student just about to finish up. He was supervised by Dr. Min Lu, which is I jumped ahead, sorry. And he's receiving this David Johnston Graduate Award in Construction Engineering in recognition of his outstanding research, instructional excellence, and contribution to the construction community. Congratulations. Next recipient is Noor, or I call her Noor Huda Saleh. She is a PhD student in Transportation Materials Engineering area, supervised by Dr. Richard Kim. She's receiving the Bruce Matthews Graduate Award in Transportation Engineering in recognition of her academic achievements in Transportation Materials Engineering. Next recipient is Dr. Harleen Sandhu. She graduated and was supervised by Dr. Abhinav Gupta in the structural engineering and mechanics area. She's receiving the Thomas Coffey Graduate Award in recognition of excellence in teaching and academic achievements. Next recipient is PhD student in geotechnical engineering, Asmayin Shariar, and he is being supervised by Dr. Mo Gabber and Dr. Montoya, and he's receiving the Thomas Coffey Award in recognition of his outstanding research contributions and leadership. Next recipient is Jonathan Woodruff. He is a PhD student in the coastal engineering area, supervised by Dr. Casey Dietrich. He is receiving the Thomas Griffin Graduate Award in recognition of his outstanding leadership skills and contribution to the coastal engineering group. I think he's not sure, Jonathan. He's not sure, yeah. Like I said, A to Z, so this is the last one. This is Chuhi Zhang. She's a PhD student in environmental engineering area, supervised by Dr. Detlef Kanape. She's receiving the Charles Smallwood Graduate Award in recognition of her excellence in research and mentorship. Thank you very much for being here. And we, like I said, the cash prize will be, it's in the mail. Trust me.
All right, and now we're going to announce our winners. It was a very close race, and in third place we have Gofun Chen.
And all three winners received almost the same amount of votes for People's Choice Award, and we're also very close from the judges. The second and first place were only 0.3 points away from each other. So in second place, we have Adam Schmidt. Let's get a drum roll going for our first place. James East.
All right, and thank you so much to everybody, to our judges for all your help during this event, to our competitors, you all did great, and to everyone who attended for making this such a great event. We'll have a reception that's basically right outside to the left, well, to your right here. And yes, so please join us outside. Thank you.